Hello and welcome back to Adapulse, the news channel that's publicly funded through Project Catalyst. So there's no coin shilling or paper motion. It's just honest reporting for the Cardano ecosystem. Now, I've got a really cool and entertaining video lined up for you today. It's got a lot of information in it that I know a lot of you want to know. And stay till the end because discuss a little bit about what came up recently regarding StakePool censoring transactions. So that's fresh. So stay till the end for that. But ultimately, we're talking about what is the function of a stake pool in Cardano. And this is by my teammate LiberLion, so from the Adapulse team. And as an SPO myself, I'm going to add a little bit of my point of view and what the real world functions are and how they operate. So I'm Josh, your presenter for Adapulse. Let's crack on with this. So first of all, to start from the beginning, you may have heard Cardano and proof of stake together in the same sentence before. So proof of stake algorithm is a consensus protocol that sort of proposes the validation of blocks through cryptocurrency holding tests, which is basically how a node is chosen to forge a block. Sounds complicated, but I'm going to break it down for you. Proof of work systems like Bitcoin or Ergo are different. So you've probably heard of crypto mining. So in this case, the miner is basically the validating node, validating the transactions. As the name suggests, the node will have to perform work that comes at a cost of time and energy. The task consists of performing an algorithmic calculation with different degrees of difficulty to basically obtain the correct results. Now, the consensus algorithm used in Cardano is called Ouroboros and is essentially the code that makes Cardano unique from other proof of stake networks. Now, the current implementation of Cardano is very modular, if you like. So check out this image showing a breakdown of the moving cogs, if you like, and how they interact with each other. So you can see we've got the node, we've got the command line interface, which we call the CLI. You've got Daedalus wallet in there, Cardano DB Sync, GraphQL, and the Smash server. So we're not going to cover all of that right now. But to go into the basics, the Cardano node is the top level component within the network. So network nodes talk to each other within the network layer, which is what makes it decentralized, as all the nodes share information. So basically, they're all singing from the same hymn sheet, if you like. So what are the nodes talking about? They're all rebroadcasting blocks and transaction information to establish a better data flow. Now, Cardano nodes maintain connections to peers that have been chosen through a custom peer selection process. I won't go into the full details of that because a lot of it is sort of back-end SPO stuff that you don't really need to know. But basically, all the relays connect to each other, so we all share the same information. Now, by running a Cardano node, you are participating and contributing to the network. How? Well, stake pools aside, every node has something called a mempool. Now, when you make a transaction, it goes into the mempool awaiting to be added to a block, which encapsulates a group of transactions. So let's say you make a transaction on Daedalus, which is a full node wallet. Your transaction goes into the mempool of that node, and as all the nodes talk to each other, all the other nodes start accepting your transaction into their mempool. Now, the important bit, every stake pool runs one anonymous node, which is a block producing node, plus at least two public relays, which are basically like typical nodes. Now, a stake pool's nodes are feeding their mempool into their block producer. So when their time to mint a block comes, all the transactions in that mempool get fed into that block, completing the transaction. The block producing node then feeds that back to its public relays. And as they are typical nodes, they communicate with everyone else, forging of that block amongst all the other relays like in the world. Now, if you're wondering why the block producing node is anonymous, it's basically so it can't be attacked, as only the pool owner's relays could talk to that producing node. You can attack the public relays, and every pool has at least two. So ATM StakePool, which is me, I have 3 relays spread across the world. So my time to spread my block is decreased. And this is called block propagation time. So if you're wondering why not attack relays instead, sounds like a plan. But the attacker actually has no idea when that pool is going to produce a block. So any kind of like random attack can be easily fixed before the block is actually scheduled. So let's go into detail about the main functions of a stake pool. Now, obviously, we forge new blocks, we verify new blocks, and we also confirm transactions. Now, it can act individually, but it also receives delegation, and you will all know that as stake. And this is from third parties, you guys, who are the users who own cryptocurrencies, in this case ADA, on the network of that pool. Now, staking is the amount of ADA delegated to a stake pool. When you're scheduled to mint a block, you are known as a slot leader. And the more stake you have, the higher your chance of being chosen, essentially. Now, Ouroboros divides Cardano time into slots, which is every second. Blocks, which are every 20 seconds, and epochs, which are every 5 days. Now, the slot is the nomination space to sign a block. Now, the slot leader, which is the node chosen by the protocol, is responsible for adding a block to the chain. There can be only one slot leader per slot. So here's some very quick and easy maths for you. Each epoch includes 432,000 slots. So as you can see below, that is 60 seconds times 60 minutes times 24 hours and times 5 days, which is the epoch. On average, the protocol design expects a block to be validated every 20 seconds, totaling 21,600 blocks per epoch. So again, see below, 3 blocks per minute, 60 minutes times 60 minutes times 24 hours times 5 days. Now, it may happen that due to various network issues, fewer blocks result, which is fine. Why? The design foresees 20 slots per block. Now, many slots are created per block to keep block production flowing. So since if a designated node is not available, another one's there to follow it up. So this is where competition between nodes occurs. And so you may have heard people talk about it. It's called a slot battle between validating nodes. And this makes the chain fork kind of all the time. So those little forks are quickly resolved and are only a few blocks long. Now, the slot battle is resolved by the verified random function, or VRF as it's known. So remember that, which is used, among other things, to find out if a stake pool was chosen as the slot leader for a particular slot. And the one with the lowest output value returned by the VRF is determined to be the winner of that slot. Now, it sounds predetermined, but it is actually random, completely random. You can minimize this risk by running multiple versions of the same block producing node, but this is massively frowned upon in the community, and it is called out, which is bad for your reputation. So, it's really not a good thing to do. The stake pool that loses, like the slot battle, doesn't collect any rewards for themselves or their delegators. So to calculate the slot signature, the factors that are taken into account are the pool's VRF key, the percentage of active staking, known as sigma in other circles, and a parameter called nonce that is random. Now, for you cockneys out there, it's not that kind of nonce. It's a combination of the phrase number that can only be used once, and is one of the input values of the VRF. So for this function, the slot ID, the nonce, and the VRF key to sign are taken as input values, generating a random value as output. If the output value is less than a certain threshold, which is determined by the StakePool staking, then it's crowned the slot leader for that particular slot. As I said earlier, the higher the staking of a pool, the more likely it is to become slot leader. So once assigned as the slot leader, the StakePool signs the block using the key evolving signature. This is known as KES signature key, along with the output computed by the VRF. Finally, this new block created by whatever StakePool is transmitted to other nodes in the network. Since a StakePool needs to be checking every second if it is chosen slot leader, it becomes imperative that it is online 100% of the time. However, we have a tool in our arsenal that tells us each epoch when our scheduled blocks are. You don't need to know much about this, apart from the fact that only the pool operator can see this. It's private, so relays don't get attacked when, scheduled as slot leader, as I mentioned earlier. But also means, we can update our nodes and carry out maintenance without the risk of missing a block because we know when they are. But anyway, the nonce value used in the VRF is used as a seed value to generate a random number. It is created by hashing the outputs generated by the first 2/3 VRFs of the blocks from the previous epoch. Sound confusing? Don't worry about it. I mean, even if a StakePool isn't forging blocks, it does play a role within the network by verifying blocks and confirming transactions. The process, when not selected as slot leader, is as follows. The StakePool uses the VRF to check if it's chosen as a slot leader for each slot. And if it isn't, it receives a new block signed by a node. Paired with theirs, the StakePool verifies the proof of the block using the VRF public key of the StakePool that signed it. And if it's valid, it is added to the local blockchain. An interesting property of Ouroboros Praus is that each StakePool tries to discover with the VRF whether or not it is chosen as the slot leader. So although the leadership assignment calendar is known in advance, the StakePools will only know which other StakePools were chosen as slot leader when the block is received and verified. Final words. The blockchain has nodes as its main network component, and the proper functioning and synchronization between them is key to scalability. Otherwise, the network would become slower due to its greater latency in its communication. But also the number of nodes has an impact on the decentralization aspect. So imagine just two unique nodes in a blockchain. Wouldn't that network configuration be dangerously centralized, since they could quite easily collude to act dishonestly, for example, by censoring transactions? Now, this caused a huge fuss, with articles reporting it as a bug in Cardano, which, is completely false. It all started with my teammate LiberLion researching for an article, and good old Conrad stating the facts that yes, we can be selective about what transactions get selected. He could have had a bit more tact, I guess, but I'm pretty sure he didn't predict this kind of response. So I just wanted to kind of clear it up for you. Firstly, this is a function present in all blockchains. But also remember that, as I keep saying, we are decentralized. So if you think of what I've just explained to you in this video, just remember, it would require all block producers to do the same for it to have an effect globally. So, you know, you can't just, it wouldn't be just one person decide some ADA handle can be blocked. No, that's not the case. You would need all block producers, all, however many there are, 3,500 or whatever, to do it at the same time. And they wouldn't do that without a reason. That's for fucking sure. But, so, this is not a bug. It's not a threat. It's just a load of engagement farming attention seekers and anti-Cardano people sensationalizing the topic. But stay tuned for LiberLion's article coming up on the subject. He's going somewhere with this, but it's a mystery. Who knows? So definitely stay tuned for that. But the last thing I want to show you is this. You can actually look up stake pools and their relays using a site called adapointearth.com. It's a bit outdated, as you can see. Like, I've changed my ticker from ATM1 to ATM like a while ago, but you can still see I have 3 relays anyway. But let's take a look at Swag. So this is Jeff's pool, one of the founders of Adapulse. As you can see, has the standard 2 relays dotted around the world. So it's a cool little tool. Wish they would update it a little bit though, but yeah. So that brings us to the end of the video for today. So I hope it's been helpful and I hope you enjoyed it at least. Remember, we're publicly funded through Project Catalyst. So we just try and give you the most honest reporting as possible. But please do remember to click the like button, hit subscribe and get that bell button so you can get notified as soon as we've got content available. I'm Josh, your presenter for Adapulse for today. And that's it. And I'll see you next time. Thanks.